Okay, the first question in the DEB 2019 mock Leaving Cert papers at higher level is to, you're given the information that 2 minus I, or 2 minus iota, is one of the roots of this cubic, where there's an unknown k on the quadratic term, minus k on the quadratic term, which is real. Okay, and you're asked to find the value of k. Okay, now the background theory we're going to use for this is that the general solution for a monic being that this is 1, is for, and I just want you to envision, I don't want to put them in a row on a real number line, because really we have real and imaginary in the Argand diagram. But what would be the picture would be you'd have roots A, B and C where these are conjugates. That's the only way that can... This condition is definitely true because the coefficients are real, and that's a theorem in our course. It's not explicitly on our course, but it is a theorem that if you've complex conjugate roots plus a real root, and you must have a real root for every cubic, and complex conjugates, then the coefficients are real. So you can do the analysis very simple. It wouldn't take long to do it here, based on z minus a expanded on z minus b expanded on z minus c would give us the z cubed minus the sum of the roots on z squared plus the sum of the cross products on z and minus the product of the roots is what f of z looks like. Okay. So when we think about this, we can find k very quickly by noting that ABC is 20. Now those minuses correspond. So ABC is 20, and A plus B plus C is k, because again those minuses correspond. Now furthermore, AB, if we make this understood coefficient to be actually explicit, it's the coefficients are 2 minus I, and its conjugate is 2 plus 1I. And when you multiply them out, you end up getting 2 squared plus 1 squared. And it doesn't matter what the sign of the actual coefficients were given for the one of the conjugates at the beginning. So it's 2 squared plus 1 squared is 5. So now I have 5 times the third root equals 20. So the third root equals 4. Now that's the answer to the next bit, but we need that quickly to fill in here. And that tells us that basically 2 minus I and 2 plus I and 4 add together to give us k. Now they cancel when you're adding, so you get the k value equals 8. Okay. Now the other two roots were 2 plus I and 4, and they were calculated in the process. Okay. So next up, we have to find minus 1 minus the root of 3I to the power of a half. Okay, so what we want to do is we want to use de Moivre, and de Moivre works ideally in polar form, so we're going to convert this number into polar form. A quick bit of a visualization: we go back 1 and down root 3, making a reference angle here of 60 degrees. Okay, making this angle here, which is the, so once you take the actual angle for this complex number, the actual angle is 240 degrees. Okay, so we can think, and furthermore, if this length here size is 1 and this length is root 3, then using Pythagoras we have that this length here is 2. So what we're really doing is we're doing 2 cos of 240 degrees plus iota times the sine of 240 degrees. Okay, so all to the power of a half. So the Mover's theorem tells us that when you're in polar form, or cos theta plus iota sine theta to the power of n, then you can distribute the power on the absolute value and distribute it in a multiplicative way on the arguments. So we do that with a half, and we get 2 to the half times the cos of 120 degrees plus iota times the sine of 120 degrees. Okay, we'll apply cast real quick, knowing, and say we'll use the complementary angle for 120 degrees, and the complementary is 60. Okay, but so you end up with 2 to the power of half minus the cos of 60. And I'm saying minus the cos of 60 because cos isn't positive here, so it must be negative. So the cost, if you like, of using the reference angle is to negate. Whereas here the reference angle can be plugged in transparently. In other words, we can just say this is equal to iota sine of 60 degrees. Okay? And remember, this is just the primary root. We do have a secondary root as well. So go ahead and call out root 2 and call this minus, what's the cos of 60? It's the same as the sine of 30. That's minus a half. Plus iota times the sine of 60 is root 3 over 2. Distribute your root 2, and you get minus root 2 over 2 plus root 6 over 2i. Or, now the effect of when there's only two roots, you're adding 180 degrees, but adding 180 degrees is the same as negating. So or root 2 over 2 minus root 6 over 2i. So they're the two answers.